Hello and welcome to our lesson on cumulative frequency diagrams. Today, we will explore how cumulative frequency differs from the graphs we've been studying so far, and we'll understand how it can be particularly useful. We'll also discuss how to choose the appropriate graph based on the category of data we have. In this lesson, we'll start by 1. Understanding what cumulative frequency is and how it differs from other ways of visualizing data. 2. Looking at various categories of data and deciding which type of graph or representation is most appropriate for each. 3. Applying our new knowledge to some practical examples to reinforce our understanding. So far, we've built a strong foundation in data terminology. This includes understanding populations, samples, discrete and continuous data, and primary versus secondary data. We've also covered grouping and organizing data, as well as visualizing it using frequency tables, time series graphs, pictograms, bar charts, histograms, pie charts, and scatter graphs. With this solid grounding, we are now ready to delve into cumulative frequency. This technique is especially useful for understanding the overall pattern of data distributions, calculating medians, quartiles, and percentiles, and making comparisons between different datasets. All right, let's dive into the main body of our lesson, focusing on cumulative frequency. Cumulative frequency is a running total of frequencies through the classes of a dataset. It helps us understand how the data accumulates over the range of the dataset, which can be particularly handy for identifying the median, quartiles, and percentiles. What makes cumulative frequency diagrams different? Unlike the other graphs we've studied, cumulative frequency diagrams always increase. This is because at each data point, we add the frequency of the current class to the sum of all previous classes. Essentially, every point on the graph tells us the total number of occurrences up to and including that class. To illustrate, let's look at an example. Imagine we are analyzing wages in a population. 10% of the population earn between £10,000 and £20,000. 7% earn between £20,000 and £25,000. Let's calculate our cumulative frequency points. For the first class, 10 to 20K, the cumulative frequency is 10%. For the second class, 20 to 25K, the cumulative frequency will be 10% plus 7% to make 17%. Calculate the cumulative frequency for every row in the table. These points will be plotted on our cumulative frequency graph. Let's now look at how to draw a cumulative frequency diagram. Step 1 is to calculate the cumulative frequencies for each class. This simply means adding each class's frequency to the sum of all previous frequencies. In step 2, we draw the axes on our graph paper. The horizontal axis, which is the x-axis, will represent the variable data. For example, wage and height. The vertical axis, which is the y-axis, will represent the cumulative frequency. For step 3, plot points. Use the upper boundary of each class interval for the x-coordinate and the cumulative frequency as the y-coordinate. Finally, for step 4, once all the points are plotted, connect them with a smooth, continuous curve. When dealing with continuous data, it's important to use the upper boundary of each class interval as the x-coordinate. For example, if the height ranges are 0.6 to 0.65 centimeters, the point would be plotted at 0.65 centimeters. Having covered various graph types, it's crucial to select the right one based on the data category. Here's a quick guide. First, frequency tables. These are great for a quick summary, but not visually intuitive. Time series graphs are ideal for showing changes over time, but they are limited to temporal data, which means data over time. Pictograms are visually engaging but can be imprecise. Bar charts are excellent for discrete data but less effective for continuous data. Histograms are perfect for continuous data but involve more calculations. Pie charts are clear for discrete data, but they are unsuitable for continuous data. Scatter graphs are useful for identifying trends, especially in discrete data. And finally, cumulative frequency diagrams show overall trends and percentiles, but they don't compare individual frequencies. Imagine you have the following frequency data for test scores of students in a class. 5 students scored between 0 and 20. 8 scored between 20 and 40, 12 scored between 40 and 60, 10 scored between 60 and 80, and 5 scored between 80 and 100. Next, we can make a table of cumulative frequencies. First, calculate the cumulative frequencies. For scores 0 to 20, the cumulative frequency is 5. For scores up to 40, calculate 5 plus 8 to get 13. For scores up to 60, add 12 to 13. For scores up to 80, add 10 to 25, which makes 35. And finally, for scores up to 100, we add 5 to 35, which gets us to 40. Then, plot these cumulative frequencies against the upper boundaries of the test score ranges. Cumulative frequency diagrams provide an easy-to-understand visual representation of how data accumulates across different intervals. This method is especially useful when you need to understand the spread and overall pattern of a dataset. In our upcoming examples, we will further explore how to use these cumulative frequency diagrams to calculate medians, quartiles, and percentiles. For now, practice creating some of your own cumulative frequency diagrams using different datasets to become comfortable with this new technique. Let's dive into some examples to see how cumulative frequency can be applied to GCSE level questions. We'll start with a simpler example and then move on to something a bit more complex. Example 1. Basic cumulative frequency table. Imagine we have the following frequency table showing the number of students who scored within certain ranges on a test. To create a cumulative frequency table, we add up the frequencies as we go down the table. The cumulative frequency column gives us a running total of the number of students scoring up to the upper limit of each range. For instance, by the time we get to the 30-40 range, a total of 25 students have scored up to 40 marks. Example 2. Using a cumulative frequency diagram. Refer to the cumulative frequency diagram provided. This diagram plots the cumulative frequencies against the upper boundaries of the score ranges. To interpret this diagram, find the point on the graph corresponding to a score of 30. The cumulative frequency at this point is 15, meaning 15 students scored 30 marks or less. To find the median score, we need the middle value. With 32 students, the median is the 16th score. Locate 16 on the cumulative frequency axis and read across to find the corresponding score. Let's say this point corresponds to a score of around 31. This means the median test score is approximately 31. Let's look at another example and find the lower quartile, median, and upper quartile using the cumulative frequency diagram. First, the lower quartile, which is known as Q1, is the 25th percentile. For 32 students, it is the 8th score. We find this by finding 25% of the total frequency, which we can do by dividing the total frequency by 4. Locate 8 on the cumulative frequency axis and read across to find the corresponding score, which is around 23.5. Now let's find the median. This is known as Q2 and lies in the middle of the data. As calculated earlier, the median is the 16th score, which is around 31. To find the upper quartile, which is known as Q3, we need to find the 75th percentile, 3/4 of the data. For 32 students, it is the 24th score. We find this by finding 75% of the total frequency. We can do this by dividing the total frequency by 4 and then multiplying this number by 3. Locate 24 on the cumulative frequency axis and read across to find the corresponding score, which might be around 38.5. Finally, let's find the interquartile range, also known as the IQR. This is calculated as the upper quartile minus the lower quartile. If Q3 is 38.5 and Q1 is 23.5, then the interquartile range equals 38.5 minus 23.5, which is equal to 15. This value gives us an indication of how spread out the middle 50% of the scores are. By practicing these techniques and understanding the type of data you have, you can choose the most effective way to represent it and draw meaningful conclusions. In today's lesson, we explored the concept of cumulative frequency and how it differs from other methods of visualizing data. We learned that cumulative frequency is a running total of frequencies that helps us to understand the accumulation of data across different classes. This method is particularly useful for identifying medians, quartiles, and percentiles, and for making comparisons between different data sets. We discussed the unique characteristic of cumulative frequency diagrams, which always increase because they represent the total number of occurrences up to and including each class. We demonstrated how to create a cumulative frequency diagram by calculating cumulative frequencies, plotting the points using the upper boundaries of class intervals, and connecting them with a smooth curve. Additionally, we covered the importance of choosing the appropriate type of graph based on the category of data we have. For example, bar charts are great for discrete data, while histograms and cumulative frequency diagrams are more suitable for continuous data. To reinforce our understanding, we applied these concepts to a practical example of student test scores, calculating cumulative frequencies and plotting them to create a cumulative frequency diagram. In summary, cumulative frequency diagrams provide a clear, visual representation of data accumulation and are valuable for understanding overall patterns and trends in a dataset. We delved deeper into using these diagrams to calculate specific statistical measures such as medians and quartiles.